All right, here we go. I'm going to go through the assignments in STAAR summative number 3 and show you, how some of them Desmos can really help you out, so you can practice that before the STAAR exam. So let's just go through these one at a time. The first here is identifying inverses graphically. And so the main point here that I want you to take away from inverses is that when you find an inverse, there are two things you want to remember. So remember, an inverse function is one that undoes the original function. If you see that word inverse, graphically what it means is flip this graph over the y-axis. So imagine folding the top left corner down to the bottom right. Another way you can check to see if you've done this exactly right is see that point here, -4, 6. If I have an inverse function, my inverse function's vertex will be at the switched x and y values. That's what an inverse is. Switch all of the x and y values, so it will actually be there at 6, -4. And you can kind of imagine, so imagine right now folding that piece of paper over. If you fold it over, that is where the vertex will lie if you fold it from corner to corner. Now I don't want that old dot, I just want the new one. And so we continue in that fashion. I'm going to keep clicking on the old one just so I can think about it. -3, 5 becomes 5, -3. And likewise, -3, 7 becomes 7, -3. We want at least 5 points, so let's just do these ones. If we have 0, 8, our new graph will be 8, 0. Oh, there we go. So see, we don't actually want that one. Okay, so I got to undo that one. And then if we want 0, 4, well, we don't actually want that one. We want to change that to 4, 0. So one more time, I want you to imagine fold that over from the top left to the top right corner. That will be your inverse function. All right, let's keep going. Second one, function equality graphically. This is one where the whole point of this exercise is to find equality graphically. And so you can almost imagine we have a whole long equation where the top of the equation is this f of x function, 0.2x to the third minus 0.23x squared plus 6x minus 1.3, or the left-hand side. And so let's go ahead and graph that. 0.2x to the third minus 2.3x squared plus 6x squared plus 6x minus 1.3. Okay, there's our first function. And our second is the absolute value of 1.4x minus 7.5. So one thing you'll notice here is these are all defined in terms of x. I actually can do this on the calculator without typing in the y equals. So not a great habit, but if you're in a rush, you can do it. So I check, I look at it, they look good. And so I'm going to find these intersection points. And remember, when you do this on Delta Math, if there are two, remember we're only looking for the x values here. I'm looking for what values of x make these the same. They're 4.143 and -0.684. Those are the two things that we're looking at. But it wants it to the nearest hundredth, and that's only 2 decimal places. So there we go. 4.14 and -0.68. Let's see. Okay, so let's see if we can find out what the error was here. -0.684. Those look good. So let's see, maybe it was something I graphed. So we have 0.2x to the third minus 2.3x squared plus 6x minus 1.3. And we get the absolute value of 1.4x, 7.5. There's a third one. This one actually had 3. There we go there. So interesting. This one had 3, 8.26. Wasn't ready for that. There we go, 8.26. That should do it there. All right, so you can see all 3 of those points there. All right, we're almost there. input output on a graph. This one is just literally, it's just making sure that you understand the difference between plugging in a number and finding what number you need to plug in. So I'm going to go through a couple of these. The graph of y equals f of x below. Find all values of x where f of x equals 8. And so remember here, f of x is just a fancy term for y. So I want you to look for y of 8 on the y-axis and go left and right till you see it. If I can't, and I can't really click on this here, when x is negative 8, when x is negative 8 on that graph, y equals positive 8. And let's see if the next screen kind of gives us a, yeah, that's all we're looking for there. We're looking for what value of x gives us y of positive 8. Versus, if I ask you to find f of negative 2, that actually means to look where x is negative 2 and see what the y value is. So it's just kind of retraining you to make sure to see the difference there between those two things. Okay, two more. Finding the roots and vertex using a calculator. So this is pure Desmos practice. Let's see, x squared plus 4x minus 115. All right, so we find the roots here. Remember the roots, and you can use Desmos here. You can zoom in really quickly here to 3 decimal places. So this is why it's really making sure you use the calculator. Negative 12.909 and 8.909. 8.909. And then the vertex, we're going to have to go all the way down here. Let's see what that vertex is. We've got the vertex is that minimum point, negative 2, comma, negative 119. So again, we're just getting practice here, making sure that A, we know what those words vertex and roots mean, B, that we're comfortable using the calculator. And so one last one, similar idea here, equations of asymptotes. So asymptotes, it's best to just kind of look at this graph and you'll see it. If we enter this graph in, it says it wants us to find the horizontal asymptotes. 5 times 1.5 to the x plus 2. So let's take a look at this thing. Okay, so remember here, horizontal means left and right. And if I look in at this thing, if I really zoom in here, what's actually happening here is that I have a horizontal asymptote at y equals 2. And if you see here, this graph keeps getting closer and closer and closer and closer to that 2, but it never goes under it. That's what a horizontal asymptote is. So there is one horizontal asymptote, and it's a horizontal line. It is at y equals 2. And so let's see, you can see the same kind of graph there going on. What number are we approaching horizontally, but we never reach as x goes out forever to the left? That's what we're looking for. Let's actually see a couple more of these so we can make sure we see one with multiple answers and a vertical one. Okay, so that's a horizontal one. Let's do another one. Let's just kind of like submit this answer. That's fine. Submit this answer. That's fine. I want to do another one with, okay, so here we go, vertical asymptotes. So let's check out this one. Let's do this graph, 3x minus 4, all divided by 6x plus 18. Okay, so what we have here, right, we also have horizontal asymptotes, left and right. It looks like left and right, we're heading towards like 0.4. We're heading towards 0.4, maybe 0.5 there. But what this question asks us about is vertical asymptotes, which basically means, are there any points in your graph where your graph heads straight up and down, right? Heads straight up and down towards infinity. And if we kind of zoom in here to look at what's going on, and I kind of look at some of these values here, let's see here. See 2.7, 2.8, 2.9. If I like go way down here, I'm still at 2.9. So it looks like we're getting closer and closer and closer. And let's make sure it's the same thing going this other way. Looks like we're getting closer and closer and closer to x of -3. So there's a vertical asymptote at x equals -3. And so we can use the graphing calculator to help us find those vertical asymptotes here.